Welcome once again in the class of water resource engineering. In coming lectures, we are going to see the groundwater hydrology. I am Mr. S. Ogule, Assistant Professor, Civil Engineering Department. Now, groundwater occurrence. Groundwater is the water that exists in the pore spaces and fractures in the rocks and sediments beneath the unsaturated zone of soil, which can flow freely into well, tunnel, and springs. Basically, is the subsurface water which flows uh, below our feet or the below the ground on which we used to stand. So the groundwater occurrence mainly depend on the porosity, the saturated and unsaturated zones. As you might have learned in the geology, there are different uh, layers of the rocks which are made up sometimes which are made up of from different materials, so which may be saturated or which have pores, or which can be don't have any pores, so it might be saturated or unsaturated depending upon the porosity, then permeability of the soil, aquifer, and storage coefficient. Now, what are the types of geological formations? There are basically four types of geological formations. First is aquifers, second aquitard, then aquiclid, aquifluge. You might have heard about the aquifers. Uh, in this lecture, we are going to see in details about all these four geological formations. So, first is the aquifer. An aquifer is a groundwater reservoir composed of geological units that are saturated with water and sufficiently permeable to yield water in usable quantity to wells and springs. So basically, when we used to dig a bore well or well, sometimes we got the spring. So these springs are from the aquifers, or these are the water flowing from the aquifers. So the sand and gravel deposits, sandstone, limestone, and fractured crystalline rocks are example of the geological unit that form aquifer. So basically it requires some pores or some cracks to store that water. Then aquifers provide two important functions. First, to transmit groundwater from the areas of recharge to areas of the discharge. So you might have heard the groundwater recharging in the rainwater harvesting, that you might have learned in the uh, building design or in environmental sometimes. Basically the recharging means where we have the this scarcity of water, so this recharged water is flowing through this aquifer to the what where is the scarcity of water due by the gravity itself, then to provide a storage medium for usable quantities of the groundwater. So it act as a storage medium, and in which the water can be used again or reused for many purposes. Then the amount of water a material can hold depend upon its porosity, as we have discussed earlier. Then types of aquifers. There are types of aquifers, that is, first is the unconfined aquifer and second is the confined aquifer. So unconfined aquifer. An unconfined aquifer is one in which the water table varies in undulating form and in slope, depending on the areas of recharge and discharge and permeability. So it is the aquifer in which water table varies in undulating form, that we are going to see in the figure in coming slide, and in slope depending upon the area of recharge and discharge. Basically, always used to tell that it is that electricity and this water flow are the kind of same thing. They are flowing from this recharge to discharge, uh, depending upon that permeability, likewise the resistance in the electricity also. So these are the things, they behave quite a similar manner. Then contour maps and profiles of the water table can be prepared from the elevation of water in wells that tap the aquifer to determine the quantities of water available and their distribution and the movement. So you might have seen, we always used to make a survey or reconnaissance, in case of when we are going to dig the bore well or the well. in surrounding area, that where is the water is available, what is the depth of water, all these things we used to ask the surrounding people. This is because of the that aquifers are there which draws or from where we can yield the water. So depending on which up to what depth we need to dig that particular well or bore, that we need to decide. So this is again another function of the aquifer. So here you can see this is the unconfined aquifer and this is the confined aquifer. So in this unconfined aquifer, water is coming from this top level and we can draw the water. And this in confined, you can see this is the layer, and because of which it has been confined, or the storage has been in the confined manner. So again, in unconfined, it can vary with the water table also, and in between you can see the stream. Again, the transpiration is there due to this vegetation. Some unsaturated zone might be there above the water table. So this is the unconfined aquifer, and this is the confined aquifer. Now the confined aquifer, also known as Artesian or pressure aquifer, occur where the groundwater is confined under pressure greater than atmospheric by overlaying relatively impermeable strata. So you can see this is the impermeable strata which is overlaying this confined aquifer, and water has been stored under the pressure in this confined aquifer. So you might have heard about the Ardesian wells, etc. in the geography. So that concept comes over here. That when we dig that wells for the water, so water comes with the pressure from this confined aquifers. So water enters into a confined aquifer in an area where confining bed rises to the surface. Water may also enter by the leakage through the confining bed. So the water enters in this confined aquifer because it is confined, but it enters from an area where the confining bed rises to the surface, and sometimes through the leakages in the confining bed. The confined aquifer display only small changes in storage and serve primarily as a conduit for conveying the water from recharge area to the location of natural or artificial discharge. So they display only small change in the storage and serve primarily as a conduit. So always it is unlikely the unconfined aquifer. There is a small change in storage because we have confinement everywhere, and it acts as a conduit for conveyance of water. Now, what is the aquitard? An aquitard is a partly permeable geological formation. It transmits water at such a slow rate that the yield is insufficient. Pumping by well is not possible. For example, a sand lenses in a clay formation will form an aquitard, also known as a leaky confined layer. So it is basically again it transmits the water but at very slow rate. So this is called as a aquitard. Then aquiclude. This is the impermeable layer of a soil that may absorb water slowly but does not transmit it. So it is impermeable layer of soil which may absorb the water slowly but does not transmit. A body of relatively impermeable rock that is capable of absorbing water slowly but does not transmit it rapidly enough to supply a well or a spring. So this thing absorb the water, but it cannot give the sufficient supply to the or transmit the water to the well or the spring. Then aquifuge. The aquifuge is the geological formation which doesn't have interconnected pores. It neither porous nor permeable, thus it can neither store water nor transmit it. Example of aquifuge is the rocks like basalt, granite, etc. without fissures. So in this geological formation, there will not be any transfer of the water because it don't have any pores or it is not a permeable. So keep all these things in mind. Basically we are focusing upon the aquifers. Then the artificial well. It is simply a well that doesn't require a pump to bring the water to the surface. This occurs when there is enough pressure in the aquifer. The pressure forces the water to the surface without any sort of assistance. So here you can see, here is the well or storage of water at the uh, height above the well. So here you can see, this is the unconfined aquifer and this is the confined aquifer. So from here water used to percolate in this unconfined aquifer. So what is happening here, and this is the lake at the downstream. So this is the water table. So what happens here? This percolated water, basically we have the storage of water at the height above from this well. This is the artesian well. So what is happening over here? We have the pressure on the water from the or the head of the water at this point. Assume this is as a pipe, and at this point we have the head of water up to like this. Obviously some losses might be there, but right now you consider as ideal stage. So we have the water table up to this, and we are digging at the well at this point. So we have enough head or water will jump. You might have seen sometimes water will jump up to this level because we have this much head. So this is the case in the aqua or artesian wells, that it does not require any assistance to bring the water out from the well. So this is the basic idea behind it. Again you can see over here also, this is the average height of water table, that is, this is the aquifer, this is the aquiclude, which is the this uh, permeable impermeable layer of soil which is absorbing water, but it is not transmitting it. So we have the aquicludes on both sides, we have the aquifer in between, and again as I showed you earlier, this is the height of water, and water used to uh, jump like this from this well when we are going to dig it. So this height is I think 876 feet, and this is the 376 feet. So water used to jump up to this height. Again, this is another example of this artesian well. So this is the confined artesian aquifer, and this is the unconfined water table. Here we have the lake or some water spring, etc. So water is percolating on this through the rainfall. This is unconfined aquifer. So here we need the assistance from the pumps or something like that. But because we have the enough head over here, so this unconfined artesian aquifer or artesian well, it does not require any assistance. Here also we have this artesian well, and we have the water table about this. So again, same example is over here. Here you can see this first water table, because we are taking the water from this well. So obviously there will be a uh, drop in water table. You can see, you can observe over here. We have the high water table over here, and this is lowering at this place. That also we are going to see in coming part. Again the same example, that is at how much water can rise and height of the uh, water table in recharge area. So as I told you earlier, this is the recharge area, this is the water table, this is the non-artesian, and this is the artesian well. So same thing is there, and the fault is present over here. So again these artesian springs are present over here. Because of the fault, the water flows out from this aquifer. Again the same examples are there. Types of stones has been shown over here, that is zone of saturation and zone of variation. This you can see the parched water table here also. So here you can see the springs. This formation you might have seen in the rainy season in the ghat sections of or ghats nearby us, that the springs used to flow throughout the year because of this stored water. And this water table is here. We have the impermeable bed of uh, clay or some other material, but because of we have this much of water storage in this sandstone, so they used to uh, flow for entire year also. And again, this is again the water table that lowers, and this is the spring. So the aquifer parameters, what are the properties of aquifer? So the porosity, specific yield, specific retention, coefficient of permeability, transmissibility, specific storage, and storage coefficient. So you can see the permeable and impermeable layers. It is this impermeable layer does not allow the water to flow, and this permeable layer allows water to flow. So the porosity, it is the uh, amount of the pores or open spaces between the soil particles. So in the sediments or sedimentary rocks, the porosity depend on the grain size, the shape of the grains, the degree of the sorting, and the degree of the cementation. So it depends on the grain size, the shape of the grains, the degree of sorting, that how much uh, or what size of the particles present over there, and the degree of cementation, that is the bond between them. In rocks, the porosity depend upon the extent, spacing, and the pattern of the cracks and the fractures. The well-rounded coarse-grained sediments usually have the higher porosity than fine-grained sediments because the grain don't fit together well. As here you can see, here no pores are present over here. This is non-porous, non-permeable. This is unconnected pore spaces, which is pore but non-permeable because we don't have the gap to flow the water. But this is the porous as well as the permeable because the connected pore spaces are there. So these are the examples. Now the specific yield. It is the ratio of the volume of the water that drains from the groundwater storage due to the attraction of gravity or by the pumping from well to the total volume of the saturated aquifer. So here you can see from the gravel, this rapid drainage is there. When the fine sand is there, the moderate drainage is there. And for clay, the slow or no drainage is there, which is quite impermeable in case of the solid rocks. Now the specific retention. It is the ratio of the volume of the water that cannot be drained out to the total volume of the saturated aquifer. The specific retention increases with the decrease in grain size. Soil having the low permeability may not easily drain out. For example, clay have high porosity but low specific yield and its permeability also low. Then the coefficient of permeability. It is the ease with which water can flow in a soil mass or rock. The coefficient of permeability K is equal to the discharge per unit area of the soil mass under unit hydraulic gradient. It is usually expressed as a centimeter per second or meter per second or meter per day, etc. The coefficient of permeability is also called as a hydraulic conductivity. Again, it is same as the uh, as I can say uh, the flow of current in the pipe conductor. So it is the kind of water is flowing through pipe. It depends on this hydraulic conductivity. Then transmissibility. It is the discharge rate of at which a water is transmitted through a unit width of aquifer under unit hydraulic gradient, which is usually expressed in meter cube per day or meter square per second, per day per meter or meter square per second. Then the specific storage, it is the amount of water per unit volume of a saturated formation that stored or expelled from the storage. Then the storage coefficient, it is the volume of water released from the storage or taken into the storage per unit of aquifer storage area per unit change in head. The storage coefficient is a dimensionless as it is the ratio of the volume of water released from the original unit volume. It ranges from zero point zero 0.02 to zero point 0.3 in unconfined aquifers. So these are the properties of this particular uh, aquifers. This is all about the aquifers. We'll stop here today. The references for this particular lectures are the slide share and the book of the irrigation engineering. Thank you.